Good morning, students. Once again, I welcome you to my video lectures on control systems. So, yesterday, for the sake of illustration, I took this example and I also sketched the root locus. This is one branch, this is another branch. So, this is how a root locus exists for this problem. So, nobody will factorize the quadratic equation and on after factorization marking the poles, it is not done so. But for you to understand what is locus diagram, I factorized the characteristic equation and I found the root locus. Today we have to understand the theory of root locus. What exactly is the theory behind root locus? That is very very interesting and you can easily follow this. Now I will put myself a question. See, this is S plane. On this S plane, there are innumerable number of points are there. For example, here, here. So innumerable, infinitesimal points are there on this S plane. Have they all participated in the root locus? For example, take this point. Is this point is on the root locus? No. Is this point on the root locus? No. There are only selected points which are on the root locus. What are those selected points? On the real axis from s equal to 0 to s equal to minus 6. So entirely the points are on the root locus. But points to the left of s equal to minus 6 or points to the right of s equal to 0, they are not on the root locus. Next, on this perpendicular bisector, the points are on the root locus. So these points have participated in the root locus, but the rest of the points are not in the picture. Why? That is a question. For example, in our country, we have 542 members of Lok Sabha. So in the ruling party, if 300 or 350 members are in the ruling party, have they all become ministers? No. Only a selected bunch of people, politicians, will become ministers. Like that. In this plane, there are selected points which are on the root locus. So these points have satisfied some condition. That is why they are on the root locus. The rest of the points, they have not satisfied the condition which we will going to derive from now, short while from now. They haven't satisfied. That is why they are not on the root locus. Understanding this is what is known as the theory of root locus. So for the points to be on the root locus, what are the conditions? That is the theory of root locus. Now today I will discuss this point. Now, as you know, now I will rub off this. No longer this is required. Now I will take up the quadratic equation, which is characteristic equation. The characteristic equation is of the general form 1 plus k GSHS. This is the quadratic equation because on the root locus, what if the locus is nothing but the path of roots. The roots belongs to characteristic equation. Therefore, in general, 1 plus k GSHS equal to 0 is the characteristic equation. Now, GS is a phasor, HS is a phasor, K is also a phasor. No, you know that. If, for example, GS can be 1 by S, or GS can be S, HS can be 1 by S, or HS can be S, or HS can be S squared. As we know that S is a phasor. Therefore, in K GSHS, GS is a phasor, HS is a phasor, K is a phasor. Now this equation is written like this. I will slightly rearrange this. K GSHS equal to minus 1. What about K? Now you take 1 by 1. K, as I said, to get the root locus, K is varied from 0 to infinity. k is a positive in quantity. It is going to have a positive value which varies from 0 to infinity. Therefore, k is a real number. Therefore, I will in polar form I will write k as k 0 degrees. GS is a phasor, HS is a phasor. Therefore, I will represent GS as mod GS angle theta 1. Next, HS as mod HS angle theta 2 equal to minus 1. So minus 1 is also a phasor. So this is yes, minus 1. Minus 1 is a phasor. So minus 1 is a phasor. How do you represent minus 1? Minus 1 is represented as in polar form 1. If you measure angle in anti-clockwise direction, it is plus 180 degree. If you measure angle in clockwise direction, it is minus 180. Therefore, minus 1 is represented as 1 plus or minus 180 or minus 180. Therefore, minus 1 is represented as 1 angle plus or minus 180 degrees. Not only 180, you can also take multiples of 180. Now 180, if you go this way, if you go by 540 degrees, 180, 360, further 180, that means 540 degrees, then also you reach this. Therefore, plus or minus 180 are odd multiples of 180 degrees. Odd multiples of 180 degrees. For example, that is I will write in this form 2q plus 1 into 180 degrees. 2q plus 1 180 degrees. Now where q equals 0, 1, 2, 3, etc. For example, q equal to 0, then it becomes 180 degrees. Next, 180 degree, 360 degree, further 180, 540 degrees. Therefore, now this I was telling plus or minus 180 are odd multiples of 180 degrees, 540, etc. So that is why I wrote odd multiples of 180 as 2q plus 1 180 degree, where q equal to 0, 1, 2, 3, etc. For example, q equal to 0, then it becomes 180. Q equal to 1, 2 plus 1, that is 3 times 180, so 540, like that. So odd multiples. So that is why I wrote 2q plus 1 180 degrees. Now from phasor algebra, this is mark A. From phasor algebra, we know that magnitudes are taken separately, angles, inclinations are taken separately. Therefore, mod K, mod GS, then mod HS. So separate magnitudes. Then angles 0 plus theta 1 plus theta 2, 0 plus theta 1 plus theta 2 are simply theta 1, theta 2. Now this is the equation. So this is the equation to understand the theory of root locus. So left hand side, if left hand side has to be equal to right hand side, then magnitudes on this side must be equal to 1. That is one condition. And phase angle on this side, on the left hand side, must be equal to phase angle on right hand side. Now what I will do is, first I will take up phase angle. This is the important condition. This is what is called as angle criterion. Angle criterion for a point to be on the root locus, the very important criterion is what is known as angle criterion. theta 1 plus theta 2 must be equal to 2q plus 1, 180 degrees. Or you take only q equal to 0. If you take q equal to 0, then it becomes 180 degree. So if theta 1, theta 2 are added, it must amount to 180 degrees. This is very important condition. In the previous example, I took the point satisfied this condition. Theta 1 plus theta 2 is equal to 180 degree. So this is what is called as angle criterion. Angle criterion. After assuring angle criterion, we must go for magnitude criterion. Magnitude criterion says that mod K, mod GS, mod HS on left hand side must be equal to 1. If you take their product, it must be 1. This is what is called as magnitude criterion. Magnitude criterion. Both are to be satisfied. For a point to be on the root locus, both the criterions are to be satisfied. This is what is called as the theory of root locus. Now in the next class, for a better understanding, I will take simple examples and I will explain again what is called as theory of root locus. Thank you.